Cool, so I guess we'll get started. So, hi everybody. I'm really excited. Today we have Pete Snyder joining us from Brave. Brave browser is a cutting-edge browser that preserves privacy for you while you're browsing around the web. And so I'm really excited to hear what he's going to share with us today. I think like more than any other browser, they're sort of pushing the frontier of what's possible in terms of protecting user privacy on the web and sort of fighting back against the way that the defaults work on the web. So I'm really excited to hear what he has to say. And you, are you currently or were you formerly at University of Chicago?
University of Illinois Chicago.
Chicago, yeah.
I graduated about a year and a half ago.
Cool, yeah, and now you do Brave as your full-time thing, right?
That's
yeah.
exactly right.
He's also the representative to the W3C which is the standards body of the web for Brave. So, cool. Take it away.
Thanks.
Hi everyone. Thanks very much for hanging out with me today. So in this talk, I'll be talking about a couple things. I'll give kind of like a non-technical but kind of high-level explanation of how we kind of got to where we are regarding privacy violations on the web and tracking and just kind of the calamity history. And then I'll talk about what Brave is doing about fingerprinting and tracking. And then I'll have some more general stuff where I'll ask you to talk amongst yourselves and make some suggestions about open privacy problems. So first, a little bit about me. I grew up in Chicago. I got my degree at the University of Illinois in Chicago. I didn't go there directly. I went to law school for a little bit, and then I moved to Anchorage and did freelance web design for a while. At one point, we sued somebody and got invited to be on the Judge Judy show. I'll have you talk about that more later. But then I came back to Chicago, got my PhD in computer science at the University of Illinois in Chicago. So now that I'm at Brave, I wear a couple different hats. I'm the privacy researcher, which means that my goal is to conduct research and publish papers about novel ways of protecting privacy online, and then also holding people's hands and helping with the engineering team to move that stuff into product. I co-chair at Ping. Ping is the privacy group at the W3C, and so we do reviews of new things that are about to get shipped into standards and try to keep them from being privacy harming. And then I do a fair amount of collaboration with academic partners, also publishing papers and working on stuff like that. And then before getting to the meat of the talk, just Brave at a very high level. Brave does a couple different things. As mentioned, we're very extremely privacy focused. That's everything we do is measured by that criteria. But beyond being just a privacy preserving tool, we also propose this alternative way of funding websites on the web. And so I won't go into too much detail, though I'd be happy to talk about it more if people had questions. But the general approach is to flip the incentive structure on the web. Right now, most sites fund themselves through advertisements. Users don't like advertisements, and so there's this agent problem where the user wants to deprive the website that they're visiting of the funding that the website needs. There's this total mismatch in terms of the incentive structure. Brave proposes a different way of doing this, where users get paid to view ads, and so users have the incentive to look at ads. Websites get funded through the payments, a portion of those payments. So Brave is primarily a browser right now, but there's a lot of infrastructure being built. There's a BAT or a cryptocurrency aspect to it, and there's a lot more. So I won't talk much more about Brave as a company for the rest of the talk, but I'd be very happy to talk about, to answer questions or anything like that if people had them. So at a very high level, here's what I'll be talking about for the next, hour and a half or so. I'll talk about why websites track, and so this will be this kind of like non-formal history of tracking on the web and how we got here. Then I'll talk about how tracking has been done, is still done predominantly on the web now, but also what enables that and how that's actually carried out. Then I'll talk about how fingerprinting makes that more complicated and how that's conducted and how that's become a replacement for this kind of classic cookie-based tracking. I'll talk about a set of categories of fingerprinting countermeasures, so how people are actually trying to prevent fingerprinting from happening online. Then I'll ask you all to do some work in terms of addressing fingerprinting surface that's currently exposed in the browser, and then I'll talk about how this stuff actually is shipped in Brave. So first, why do websites track what's going on, and why in the world did people build a system that enables this? I also want to say this is pretty informal, especially at the very beginning, so I really want to encourage people, if they have questions, interrupt me at any given time. If something's not clear, if something just doesn't make sense, or if you just have something to add, please jump in. Okay, so why does tracking exist? Why is this enabled in the web? So way back when most of our news came from paper and this kind of thing. People realized that you could sell ads against this stuff, and people who bought a certain type of paper would be maybe more likely to buy a certain type of paint or a certain type of meat or a certain type of whatever else. And so people would place ads next to the kind of content that the people who might buy those products would buy. And so here, in this kind of classic model, people weren't tracking users, they were tracking content, and on the second order expectation that people who consume that content would also want a certain type of product. And so you had ads like this, which again, are they're being matched against the content, not against the person reading the paper. That's important. And the reason that matters is because even way back then, or still going on now, but predominantly when these kinds of paper publications were the predominant way of sharing information, even then people were trying to target users. And so this would happen if you, say, signed up for a magazine, people would buy magazine subscription lists on the idea of being like, these are people who like a thing, so I'm going to try to track these people across different populations and sell ads to them. So even in a pre-online world, there's some effort to track people or to match ads against people, but predominantly you're matching ads against content. Then the web becomes a concern, and people start there's the exact same model. So at the very beginning, you have these kind of dumb ads or unintelligent ads where they're just people put an ad on a page because they think it's related to the page content on this theory that people who look at the page will also be interested in the ad. You're matching the ad against the content. And then very quickly on, though, this is probably before most folks in this room were online, but you had these things called web rings, where basically websites would self-identify on some topic. They would form an organization amongst themselves, where those were people who like Disney or The Simpsons or whatever it might be. And they would swap ads amongst themselves. And so all the Disney sites would advertise for some other Disney site. Every Simpsons site would advertise to some other Simpsons site, this kind of thing. These were called web rings, so they had a bunch of different names. And so just as with print publications, there starts to be some effort to track people across websites, but you're not tracking the person themselves, you're inferring their interest across time. But then, as technology gets more sophisticated and people start pushing these things to third parties and there's specialization on the web, you get a situation where ads are no longer tracked by the interest of the website, but tracked by the interest of the person. And this seems like a tiny shift, but ends up being pretty fundamental for tracking online. And so for folks not familiar with how this actually works in practice, at a very, very high level, ads like this get iframed in. When the browser makes some request for the iframe, for the content in the iframe, it sends along some information derived about the user. So that might be purchasing history, it might be name, it might be location, it might be a bunch of different things. But then the third party makes the choice about what to return the content. So there may be some matching of the ad against the content, but primarily you're matching against the person looking at the content. This is where things start to go sideways. So you have these third parties where they have a foothold on a large number of different sites, and they start to build up these massive databases of information on per person. So these parties can see when somebody visits, that one person might visit these 4 sites here, and another person might visit some subset of them and some additional sites that aren't listed, this kind of thing. But all this information gets collected in these large, to users invisible databases that are basically just tracking, this is a person, and this is what the types of sites they like to look at. And so now, when you have a website that may be very low quality and have content that people don't particularly care about, you can still do the same sort of thing. The quality of the ad is no longer connected to the quality of the content. This has pretty massive repercussions for why the web is so terrible, or has the problems it does right now. Is that good in quotation marks ads can be matched against the same people on bad websites. And so, presumably, we think that these are my hometown newspapers. These newspapers are producing high quality content. This arbitrarily bad website on the other side of this page are producing low quality content. And if we had an old business model, it would cost a lot of money to attract or to get ads in front of the people who looked at news, and there'd be very little benefit in putting ads against rarely seen or rarely desirable websites. But what we see is revenues moving from high-quality websites to low-quality websites because advertisers don't have to target the websites, they can target the users. And so put different, oh, sure.
When you're talking about cost, is it cost per website or per user visiting the website?
This is the cost the publisher pays. Well, there's 2 different costs. This is the cost that the advertiser pays to the ad network, which is kind of sort of a proxy for what the advertiser pays to the person, to the website owner.
But that would be per
Sure, but that is absolutely true. But there's the two important dynamics here are, one is that money is being siphoned away from the other because there's no longer any incentive to put advertisements on the high quality content, because you can get the exact same people on 1,000 different poor quality websites. And so it ends up being beneficial for the poor quality websites because they can at least get some ad revenue, because there's some marginal improvement in the quality of the ad placement. That's one thing, and the other thing is that it harms the people who are making the content that you want to attract to.
But presumably the high quality website still has incentive because you will attract more users, and so total revenue would be higher. Let's say per written word will get more visitors, and you'll be able to profit from that.
So no, so that is how the system is supposed to work, but in practice that's not how it works, because the advertiser may get their ad in front of. Say we have some very simplified distribution of web usage, and 50% of the time people go to just Chicago Tribune, and 50% of the time they go to everywhere else. You might think that, okay, advertisers are going to spend 50% of their ad spend budget on Chicago Tribune, 50% everywhere else. But that ends up being not what happens, because it costs much more to put an ad on the Chicago Tribune than everywhere else. And so even if the Chicago Tribune is still making more per day putting ads, all the money is being siphoned away to other places because they're much, much cheaper to go. So your ad spend dollar goes much further if you target crummy websites than quality websites. So even if the absolute income to the Chicago Tribune is higher than the crummy website, the marginal decrease is dramatically larger for the Chicago Tribune than the marginal improvement to the crummy website. Does that make sense? This dynamic is pretty important for understanding not just advertising online, but why websites like Breitbart.com make a lot of money and other websites don't. I don't mean anything political by this. I have my own political opinions, of course. I just mean that I think even among people who find Breitbart.com appealing, they would agree that there's less reporting and less original work being done by that website than there are the people on the other side of the column, setting aside people's might included political preferences. So the new strategy for online tracking is to identify the kinds of people who go to these sites, but then place ads against them everywhere else on the web. And so what is a down target effect of this? I don't know if people are familiar with this story. Have you already talked about this? So this is a pretty horrible situation where there's a late teenager woman who is pregnant. She had reasons for not wanting her father to know, but Target started sending information about pregnancy clothes and maternity wear and this sort of thing to the house, and the dad found out that the daughter was pregnant because of Target, not because of the daughter. So all this is to say is it's not just about defunding websites, although that's a pretty horrible implication in itself. You have these very kind of insidious downstream effects of the tracking that the system enables. And so this is what things look like right now. This is not a complete list. This is not a complete list for two reasons. One is because people are constantly going out of business and jumping in, but also because there's just many, many, many more names that you may or may not know that are not on this list. But the point is that there's an enormous number of middle parties that exist only to build databases about people and to figure out what kind of person is going onto one website. A side effect is that almost every company you see on this list is not profitable. That is true almost entirely across the board. If you're not Google and you're not Facebook and you're selling ads, you are almost for sure not a profitable company. You're making a long-term bet about something, but that's just an empirical fact. Okay, so that's how tracking works and kind of how we got here, but how much of this is actually happening? So I want to refer you to this paper. This came out about 5 years ago, semi-recent, but the numbers are a little bit out of date, but the general direction of them is accurate. So this is work that was done at Princeton. Stephen Engelhardt, by the way, is now basically has my job at Mozilla. He's a privacy engineer there. Arvind is kind of a mild celebrity in the world. I don't know if you've talked about him, but he's an incredibly cool dude and does a lot of internet privacy work and is just an all-around great guy. So they did this paper where they basically visited 1 million websites, measured what third-party resources were requested, categorized those third-party websites in some ways, and basically had this kind of census of how much tracking is actually happening online. So I'll show you 3 figures from the paper, although the entire paper is interesting. What they find here is that even on just the average website, something between almost 20 different tracking parties understand what's going on there. So there's 20, you can think about that as something on the first order of 20 different databases get a row inserted to say that you looked at a website. That's just on the average website, just the median website. And a slightly larger number of people would have the technological capability of recording that information, but don't. So they're not categorized as trackers, but they have the same vantage point or the same information access that trackers do. So something like 20 different people know every time you visit our website. So what are those 20 people? Unsurprisingly, if you look at the far side of the room, it's not equally distributed. So things that belong to Google Analytics is by far the most popular tracker online. This number is above 80% now. These numbers are a little bit old, but you should think about it as like the Google Analytics database has a record of 70% of the websites that you view. And that is a database that you don't get to edit, you don't get to audit, you don't get to whatever.
First 5 are all Google too.
So the next table is just groups these by organization. And you can see, unsurprisingly, the only 2 profitable advertising companies are up here, and everybody else here is, in their advertising budgets at least, losing money. That is, I'm trying to think if there's any exceptions to that rule right now. I don't see any that have turned profitable. But yeah, so Google basically, by having a bunch of different vantage points, which are mostly Google Analytics, but things like Google Fonts and Google Maps and things like that, understand about 80% of websites you view.
Sorry, what's terminology with percent first parties?
Oh, so sorry, first party. So this is generally first party means the top level URL frame. So whatever you type in the URL, that's the first party. The first party is usually, although not always, considered to be that domain. Do you know what an ETLD is? TLD is top level domain name, so that's like .com. ETLD is effective top level domain. So now there's a bunch, like co.uk is 2 domain names, right? But effectively that's 1. So ETLD is something like that. ETLD plus 1 is the top level domain, effective top level domain plus 1. So if I register a website like CNN or whatever, Pete Snyder at co.uk, the ETLD is co.uk. The ETLD plus 1 is petesnyder.co.uk, and anything else is considered a subdomain. So if you cluster everything by ETLD plus 1, which is just a general heuristic that's used on the web, that is the first party. So that's like, static.cnn.com and fonts.cnn.com or whatever. That's all considered the first party. The third party is every other page. Sometimes that gets divvied up by third-party resources operating in the first-party context. So if I load some third-party code in the first-party frame, sometimes that'll be considered first-party, sometimes that'll be considered third-party, depending on the kind of measurement you're taking. Sometimes third-party just means iframes.
Could you clarify exactly what non-tracked content would be?
So if I have for example, say I link to a CDN or like an image hosted on a CDN, that CDN may make explicit guarantees. Like Fastly is a CDN that's very popular that makes explicit privacy guarantees saying we won't record IP addresses beyond this period of time, we don't record anything else, we don't set cookies, this kind of thing. Fastly could violate that promise at any point they do, but they make legal guarantees to not be trackers, and so they're the organizations like that are this pale blue bar. People who could do tracking or at least have the technological capability to do tracking, but for various reasons aren't believed to be doing tracking. Cool, so there's a lot, short story, there's a lot of tracking going on. I'll pause for a second, any questions? I mean that just kind of as a background to explain why tracking is profitable, why so many people are interested in doing it, that kind of thing. Any questions before I jump in further?
So the 80% Google first party graph, that just means that that's JavaScript code that is, that's mostly Google Analytics that's running on sites directly in the first party context?
Mostly two slight clarifications. One is that it's not, and this one is Google Analytics, this one is all Google properties. So this is Google the company, not Google any particular resource. So this would group together Google Maps and Google Fonts and Google Analytics and all this kind of stuff.
And it's first party because the user visited those URLs?
No, it's first party because the way the resource was included in the first party, it's able to determine what the first party was. So if I pound include my Google Analytics script, that's a third party resource, but it has access to, it can determine what the first party is, and so it can record the first party behaviors. Yeah, so the way to understand this is Google has a way of understanding at this point greater than, but something on the order of recording 80% of the first-party URLs you visit. Cool. Okay, so that's why websites track and kind of where we are. So now I'll talk about how tracking is usually carried out, like the common case. Before I jump in, this is Brendan Ike. I don't know if people are familiar with Brendan Ike. Brendan Ike is the person who owns Brave. He's indirectly my boss. He's an extremely important person in understanding the history of the web. He's the person who invented JavaScript, more or less in 10 days. That's kind of a little, that's not 100% true, but that's mostly true, is that he went from somebody at Microsoft, or sorry, somebody at Netscape said, we need something like this, and he said, okay, I can get this done, and came up with the prototype in 10 days. Pretty astonishing dude. He also did the initial version of the web API, so anytime you hear something called DOM0, that's not 100%, but largely decisions inspired by Brendan. Brendan was an early guy at Netscape, an alumna of UIUC. He was an important person at Firefox for a long time, and he's responsible for Brave and BAT. He's the person who kicked this all off. Brendan is an amazing dude. Oh, sorry, I bring him up though because the reason I want to mention him is that the mechanism I'm about to describe for how tracking happens in the common case is something that's enabled by Brendan's choices and totally unintended by Brendan's choices. So when people explain or understand how the web works, it's not supposed to work this way. This is not the intended purpose for any of this stuff. This is a bunch of decisions that got made under extreme pressure when Netscape was about to go broke any other day, and has these enormous downstream consequences. So if anybody ever says, well, this is what the standard requires, so we should do it, you should keep that in mind, that this is a lot of accidents. Okay, so back like Web 0.0, when it was still like a research project, or the simplest form of it, I'm sure you all know this, but the simple version is you make some requests, there's no state attached, and the server responds. And then if I make another request, same thing. There's no state carried between these two operations. This is like classic web way back in the day when it's still a project at CERN. So this has some problems. So if, say, I want to have a server that can distinguish between different types of users, how do I do authentication? How do I don't want to make people type their password on every single page view. I need some way of carrying that state along. And even though HTTP has a way of doing authentication, it's pretty crummy for for an enormous number of reasons that I can go into, but nobody uses it for a good reason beyond, I think literally the W3C is the only website I know that uses HTTP auth. It's not great. And so the solution was at a high level, so we'll have some way of transmitting tokens across browser views or page views. We'll have some standard for describing state that gets tracked in the browser, and this ends up being called cookies. So a cookie is just at a high level a value that the server gives you, and you return it on every subsequent request. So now, when I make my request to a server, it returns the content and also some cookie identifier, so ID XYZ. And then when I visit it again later, I return that value, and the good site says, okay, XYZ is a valid token, I'll give you back the secret resource, but if somebody else comes along and requests without that ID, the server will reject the request. So that's column one. There's a separate column of things going on at the same time that end up enabling tracking. Second is that lots of websites host lots of images, and maybe not so much now, but particularly back in the 90s, all this stuff is extremely expensive. Finding hosting was something you paid for in a large amount of money. And so when websites would do this kind of thing and host the same image, this ended up costing a not trivial amount of money, and not the kind of thing that would just get pocket change. And so people would want to refer to images across domains. And so even though there's just one, there's the image now becomes a third-party request of Cozy Kittens or whatever. Uh-oh. There. And so the question was, what do we send cookies on this request? It's a third-party request. What should we do? And largely because of rushing and the specification being unclear and a bunch of different things, the decision was made to include cookies on this request. And so third-party cookies became a thing and a way that tracking could be done. And so yeah, this is fundamentally what's going on here. Cookies plus sending cookies on third-party resources is the primitive that allows people to track people across websites. That's not 100% true, but that's, to a first approximation, 90% of the trouble. And so how does it actually end up getting weaponized? I make some request to site A. Site A returns information that makes me issue a request to the tracking site. The tracking site sets up cookie, and so now when I make a request to site B, I return that same cookie. and this tracking site is able to learn that I've visited both site A and site B. It's extremely simple, extremely uncomplicated, but this is what almost every tracking system that people care about online does. Yeah, so I guess I gave this away earlier, but the point is that Brendan opens up, or at least I've heard Brendan open up maybe a dozen talks at this point where he says, I invented JavaScript in the 90s, and I invented the DOM in the 90s, and I've been apologizing for it ever since. Yeah, I think Brave is as privacy respecting as it is because Brendan has some like background guilt going on. I say jokingly. Okay, so how does the story advances though that a lot of browsers notice this is happening. A lot, though not all, browsers think this is unacceptable and start fighting back a little bit. So Safari is probably the first person to take an extremely strong stand about this. Although Firefox also early on blocked third-party cookies, although ended up rolling that back. And so right now, a number of large browsers, Brave included, say no third-party cookies or have some restrictions on the kind of third-party cookies that get sent. So as a countermeasure, sites started saying, okay, we're not going to use cookies, we're going to use URL parameters, and we'll store these values somewhere else. So instead of storing in a cookie, we'll store it in local storage. Or I guess I shouldn't assume too much. Are people familiar with these things? I can talk through them. HSTS is a way of describing a cookie upgrade, that a resource should never be requested in an unencrypted channel. You can do tracking through that, the other stuff, whatever. But the point being that people who wanted to do tracking started to get a lot more sophisticated about how they were going to store these values. Have you ever heard like what an evercookie is? An evercookie is a not precise term basically for storing unique identifiers in places where you wouldn't expect to find unique identifiers. And some of these things can be extremely insidious. Just show of hands, who knows how HSTS tracking works? This is kind of the absolute grossest example about how a security feature can be co-opted for tracking. HSTS allows the site to say, when I make a request, it returns a header that says, never make a request or never make a request to me again over an unencrypted channel. So even if the link says HTTP, automatically upgrade it to HTTPS. That's a great feature, right? But what some advertisers realize is that we can make arbitrarily long domain names, so I could have tracker.a.b.c.e, whatever, arbitrarily nested, and we can set a different set of HSTS instructions for every subdomain. And we can do that differently for every user. And now if I have nested subdomains of length, I don't know, 32, I have 32 bits that I can set, 32 yes-no values I can set for each user, and now I can uniquely identify everybody on the planet. So the point is just that people are extremely sophisticated about this stuff, and it gets really nasty. So Brave has its own countermeasures against this. Safari has their own countermeasures. But if people can figure out a way to leverage something to track you, you can be sure it's happening right now. Okay, I will pause for questions. But the point just being, that's how it used to happen, and now it gets a lot more complicated real quick. Cool, okay. So now, fingerprinting. Fingerprinting you can think about as like tracking hard mode. So if in the classic mode, the website would just find somewhere to put storage on the device, then figure out some way to read that storage back. Fingerprinting isn't about storing values. It's about determining unique characteristics of each browser and using that to identify them. And so how is this done? Well, in a whole bunch of ways where you might not expect. So your browser window might be a different size than your neighbor's. That's somewhat identifying. You might have some bizarre font that you picked up at some point to make a PowerPoint presentation, and that's unique. That's going to uniquely identify you, at least somewhat. Your hardware will be different. Maybe you picked up a plugin at some point. Whatever. All these things. None of these things are uniquely identifying, but if you combine them together, you get a set that becomes very identifying. So here's a toy example of this. Consider this to be the set of all internet users, so something like 3 to 4 billion people. And you're one person among 3 to 4 billion people. And so the tracker's challenge is to identify you from everybody else without storing state anywhere. So you might think, Firefox users, there's let's see, Firefox is 20% of the web, so there's hundreds of millions of people using Firefox. That's not identifying at all. I'm pretty private. In Windows, almost everybody uses Windows still, right? So that's also pretty private. Lots of people have Office installed, so this is also pretty not too identifying. DNT, do not track, if people are familiar with that. This is this terrible, or not terrible, a well-meaning idea where basically your browser could send a header to a website to say, please don't track me. That's it. But the expectation was that people would respect that and not track you. I think Twitter is the only person who ever actually reads this value currently. But the point being that some browsers send and some browsers don't. But that is also semi-uniquely identifying. So if you go into Firefox and say, don't send the do not track header, all of a sudden that's another entropy bit. Are you using an ad blocker? Everybody uses ad blockers, but at some point, like the little set at the middle becomes extremely tiny, right? Even if all these things have millions of people in them or billions of people in them, you may be the only person who has all these particular parameters. So this, in a nutshell, is how fingerprinting works, is to find enough of these kind of subset intersections to identify each individual person. So two characteristics come out of this, that to be successful at fingerprinting, you need two things. You need a large number of semi-unique identifiers you can pull off people, and you might be able to trade that against a smaller number of very uniquely identifying identifiers. But protecting against fingerprinting means kind of fighting on both of these fronts. Okay, so I won't begin to go through the entire set of fingerprinting points, but I'll talk through 4 of them as an example, and ask you about the 5th one. All right, so the user agent string, there is an extremely kind of funny or just maybe interesting explanation of how in the world we got into use this identifies Chrome, how in the world that could possibly be. So I just want to refer you to that if you're interested. But the point being that over time, for web compatibility reasons, each one of these parameters got added on to the point where Chrome sends strings that seem to identify Mozilla and KHTML, which was the predecessor of WebKit and Safari and blah, blah, blah. So this, in most browsers, this gets sent on every single page request. And so you might think, again, you're in the Mozilla, or sorry, you're in the set of Chrome users. That's pretty good, but this value is going to change frequently. This value is going to be different depending on platform. This is going to be different. This will be different, et cetera. So already there's a whole bunch of semi-identifiers in this thing that you're sending to every single website. And this is also this is easy to get to. It's exposed in JavaScript at navigator.useragent. And it's also just sent as a HTTP header to most websites by default. Any questions about this? It gets a little bit more buck wild from here. Cool. Okay. So then this is kind of the craziest one, or at least the one that I find most frustrating. So right now, when a web browser visits a website, it reads the CSS, whatever, and in CSS you can say use this font for this element, use this font for this element, et cetera, et cetera. And there's a semi-complicated algorithm for figuring out how to match the font on your system with the name that's in CSS. And so the way the standard works is that it categorizes all fonts into 1 of 3 categories. System fonts are the fonts that, if you're using Windows, Microsoft provides by default. If you're using OS X, that Apple provides by default, whatever. But those are the system fonts are ones provided by the system. Web fonts are ones that the web page includes using a variety of different ways, but the web page instructs the browser to go and download it somewhere. Local fonts is this middle ground of fonts that the user has installed to the platform. And so it's in this local section where you can fingerprint people. So say that you've installed Office or Photoshop, or for whatever reason you've installed fonts, web pages can read those back out. And so even if the vast majority of people have only the system fonts and then one oddball font, that one oddball font is likely to not be on anybody else's system, or at least be on a very small number of other people's system. So every font is a bit of entropy. And so there's no API specifically to say, tell me all the fonts in the system, but the way websites extract this is kind of annoying. So websites, it's done by this. So websites will just have some list of, extremely long list of fonts. So it'll be hundreds or thousands of fonts, just the names of fonts. And then we'll create some page element like this. And the fingerprinting font will just read, it'll just iterate over the list of fonts, try to apply that font to the text, and then see if the size of the span changes. And so if it changes, then it knows that the user has the font. And if it doesn't, it knows that the browser is ignoring it and that it doesn't have a font. So even though there's no specific way for the web page to say, tell me about all the fonts the user has installed, you can infer them through this indirect way. 2 characteristics about this that are important is if you're someone protecting against this, it's extremely difficult to think what is the defense you're going to deploy here. You can't stop websites from reading the width of elements, right? That's going to break a gazillion different websites. You also presumably don't want to say you can only use these 6 fonts. So figuring out like practical countermeasures to get against this ends up being difficult. I'll talk about some ways that browsers have some browsers have tried to mitigate this, but think about this as kind of a hard case.
So is this used in combination with cookies to like identify you? Like, say if I like, you know, I installed a new font, does that like categorize me as someone new, or is there some way to like integrate it?
So generally what happens is, to a first approximation, like the logic is, if the tracking party sees a cookie, it looks to see, is this a cookie I recognize from somewhere else? If so, stop, I've identified the user. If this is a cookie I've never seen before, also take a whole bunch of different like try to identify the person through all these kind of fingerprinting methods, and use that to what's called cookie syncing, and identify this cookie and this cookie both identify the same person. And the fingerprinting like this is the mechanism that cookie syncing or cookie linking ends up happening. So you can think about there's just some higher table that says these 50 cookies all identify the same person. This exists. Well, I'll save that to later to talking about countermeasures in browsers. But yeah, this cookie syncing thing is an extremely difficult problem to work around if you are working on practical web privacy stuff.
Does Brave have any defenses against this? Or are you going to talk about that later?
Sure. Yeah. I'll say that we have some defenses against this that are unsatisfying. Our two-pronged kind of approach is try to fix the standard. That will be very useful if we can get that fixed, although the Blink team is very resistant against that, although Mozilla and Apple are in a much more privacy-preserving point of view. So if we can fix the standard, then all of a sudden Brave gets the fix for free because it gets implemented in upstream Chromium. In the meantime, what we can do is, well, there's a couple of different approaches. One is that we can just say local fonts is always 0. That's appealing for most English language websites and most Western websites. That'll be fine. But there is a not trivial number of sites that are particularly in Asia that basically all but require a certain set of well-known fonts to be installed that are not provided by operating systems, or that the quality of the fonts that are provided by operating systems are so poor that it's very common for people to use these local fonts. So saying just that local fonts is an empty set breaks websites for a non-trivial number of people. It seems the proposed alternatives are to either try to build consistent mappings between the requested language. So browsers advertise, please give me text in this language in a number of different ways. And if you can map a small set of possible local fonts to the language, you can probably at least keep people in a pretty big anonymity set. Anonymity set is just a kind of a general way of saying how many people do I look similar to. And so a larger anonymity set is more private, a small anonymity set is less private. Yeah, so if we can build these mappings of languages to possible fonts, that at least keeps, like, I don't know, the icicle font out of what gets enumerated. And you might be able to limit the amount of fonts that people can identify to like 5 per language instead of 5,000. And that would be useful. The other approach is to say, put things behind like a permission prompt, or ask users to opt in fonts they want to put on the web in the browser instead of just inferring everyone on the system. And then that would solve the common case harm of I installed some font 3 years ago, completely forgot about it, and now it's allowing me to be uniquely identified on the web. But to answer your question directly, Brave right now does neither of those things.
Would it be possible to kind of swap in the missing local font for a web font and kind of lazily download it or something?
So that would be fantastic for if we could get website authors to do that. But if the problem is website users, then you still have the exact same privacy harm. Because I can then infer by looking at the network traffic whether or not the person is using that font because they go and request it. If I understand what you're saying, right?
But presumably, maybe those fonts would have some third-party storage, at least not some repository of fonts that you would download all missing fonts from.
Oh, so you're saying that if I'm in this case, instead of for every iteration here, I go and download another font.
Yeah.
So that would give you the privacy benefit, but fonts are 1 to 2 megabytes in size. And so if someone's testing 5,000 fonts, you've just killed your website. because that's a gig of data or something. But whatever, it's a not trivial amount of data, and if you're on mobile, you've just cost the user $20 or whatever. So I mean that would have a nice privacy property though. Okay, this one is kind of particularly interesting. There's two versions of this kind of fingerprinting. All this stuff comes out of a paper, or all this stuff was kind of initially identified in a paper that came out of UCSD, I think. Boy, I hope I'm remembering right. But this paper at the top, I'll say a little bit more about Hoav because he's a particularly cool dude. But yeah, the approach described here is to basically, at a high level, I'm going to do some drawing on do people know what Canvas is? Cool. So yeah, I'm going to do some drawing. Canvas is this API that allows you to, like, instead of writing text or squares, you can draw a line and a circle and whatever. You can do arbitrary drawing. So I'm going to instruct the browser to do some set of drawing operations, and then I'm going to read it back out. And in extremely subtle different ways, different hardware platforms and different browsers do this extremely subtly different. And so even though it will almost always look imperceptibly different to the user, there will be extremely small, or there are often extremely small differences that will be due to color depth and the graphics card and whatever else.
So you're saying JavaScript can read the output of the canvas, like all the pixels?
Yeah. So the way, there's two ways of doing it. It doesn't get to iterate over, like, say, pixel 1, pixel 2, like that. But there's two APIs that allow you to read the contents of it back out, either as a blob or as a data URL. And so you can use that. And even if the data URL, you could, or actually both of those, you could translate back into some other data structure that you could iterate over. I mean, you might ask, why in the world is there this API to say, like, what is the use case for reading things that you presumably already know are there because you drew them? Why did browsers include this? That's a great question. But this API exists, and not a lot, but a not zero number of websites use it for non-malicious purposes. Actually, it's funny, the main use for this, the main not tracking use for this to data URL method on canvases is to detect whether or not the current platform has emoji support. And so you draw, like, the smiley face, and then you say, did the canvas change at all? No, then this user's on a platform that doesn't support emojis. Yeah, I mean, all this stuff gets adopted for all sorts of extremely difficult to predict kind of things. Oh, yeah.
Isn't the, like, obvious use case, so, like, you have a paint app and you're drawing, and then you want to, like, save the drawing as a JPEG?
So I think, I mean, that is like the benign purpose. But presumably, if I know the instructions that went into drawing the canvas, I can recreate that in some other way. But yeah, I mean, that is why that exists. Okay. I only mean that if I put the information into the system, I should already have it somewhere else that I don't need to read it back out of the system. So what this actually looks like is, this is an image just taken from the paper, but this is what the user drew. So these are the graphics, like the 3D graphics instruction, the OpenGL graphics instructions they issued to the website. And these are all extremely subtle. These are where each graphics card rendered things slightly different from the other ones. So this is, like, you can think about this as, this is your ground truth. This is the difference. This is the difference between them across different platforms. And you can see that different graphics cards have these differences that may or may not be subtle, but are usually imperceivable to users. And so by finding these differences, then I can fingerprint people in this way that I expect the people who made this API did not anticipate. I just want to say something else about Hoav. Hoav is such a cool dude. Not only, if you've ever heard about return-oriented programming, he is largely responsible for that. From this paper, which I think has the greatest title of any paper I've ever read, Geometry of Innocent Flesh on the Bone sounds like literature to me and not something about jacking computers. But yeah, Hoav is just an extremely cool dude. So I wanted to shout him out. Oh, sorry.
You said that canvas printing, fingerprinting allows you to differentiate different graphics card or what renders they're using.
Mm-hmm.
But doesn't the browser also send the graphics card, the WebGL renderer, as one of the headers?
It's a header. Can you say more? I'm not sure I follow you. Wait, sorry?
Doesn't the browser also send the graphics card on the machine as one of the headers?
I don't think so. What header are you thinking of? I might be missing something.
Could be wrong. I was just reading some article and I thought it was the WebGL renderer that was sent with it.
You might be thinking of it. I could be mistaken, but you might be thinking of this proposal that comes out of Google called Client Hints, where the website can request the browser to send additional information on the next request about different things. So it might be height and width, and it might be that graphics capabilities was one of those. You might also be thinking of, I don't think I've ever seen this, but it's not impossible that some browsers would send in the accept, oh shoot, what is that one called? It's not called accept lang. Except hyphen this phrase that I'm not remembering, but basically says I can understand this image format and I can understand this text and I can understand XHTML and whatever, and it might be that there's some browser at some point made the choice to include that in that string. I'm not familiar with any browsers that do that, but it's definitely not, that might be what you're thinking of. It might be something I'm not familiar with. Any other questions? Cool, okay, well then, sorry, I'm going a little bit behind schedule, so I'll try to pick up the pace. There's also a not trivial number of APIs that will just straight up tell you, like, here's a aspect of the hardware that I'm on. It usually won't say, like, I'm MacBook whatever with 4 USB ports and whatever, but you can infer a whole bunch of this stuff very quickly. So there's an API that's not completely standardized, but ships in Chromium browsers that will tell you the number of hardware cores you have. So you can do some amount of concurrency with workers threads if you want to. The Web Audio API will tell you the number of channels on the machine, audio channels, whether you have stereo or 5.1 or whatever that might be. The WebGL API will tell you the number of shaders you can support and some information about SIMD instructions and stuff like this. There's a not standardized but shipping in all Chromium browsers device memory endpoint that will tell you a binned version of how much RAM you have in the machine. And then there's a whole bunch of ways through a whole bunch of different network touching APIs that will basically allow you to learn things like, am I on Ethernet or am I on Wi-Fi right now? What is my IP address? What is a bunch? What are the capabilities of the hardware devices that are in the platform right now? None of these things require permissions. So every website gets access to all this stuff across the board currently. That's bad, but that's the state of things. Yeah. So I just mean to highlight that these are all extremely trivial. Any piece of script can get to these. You don't need a permission. You don't need anything like that, at least if you're following the standard. Okay, last. So height and width. I mentioned before the height and width is identifying. Does anyone have any idea of how you would extract this? There's an easy answer and a hard answer. The easy answer is just to go window.height, window.width, and guess from there. But can anyone suggest an alternative to this? This is what makes it so difficult to deal with. So say I don't get to execute JavaScript or something like that, but I wanted to determine the height and width for fingerprinting purposes. How would I go about that?
Based off of the body tag or a div that you create, because you can read the height and width of elements.
So you could, let's say I don't get to use JavaScript though. If I understand you right.
Maybe the browser loads something lazily, and then if you have a small window and you don't think
Exactly, yeah. So it's very easy to lie about window.width or whatever, but it's very difficult to lie about, am I actually displaying this image, or what's the text flow currently, or this kind of thing. And so this is why this ends up being probably the most identifying feature of your browser, and also the one that's hardest to deal with. I can talk a little bit about how people are trying to deal with it, but that's the sad truth. Okay. Are people familiar with, so the EFF is a terrific organization that's based in San Francisco. They do mostly privacy privacy work, a little bit of legal work, but mostly technical solutions. If you've ever used Privacy Browser, or Privacy Badger, they're the authors of that tool. If you ever use HTTPS Everywhere, they are the people who originated that project, or at least co-originated that project. I just say that they're fantastic people. They also put out this paper a while ago, this would be like 10 years ago now, called Panopticlick. You can visit in your browser right now, and what Panopticlick will do is it'll do not even all these things that we've talked about, a subset of the kind of identifiers that we just talked about, and it'll tell you how identifying you are. So it'll say, I can detect you 1 out of 100 people, 1 out of 1,000 people, using just an extremely non-aggressive set of fingerprinting variables. So when a lot of websites or a lot of browsers say they want to improve browser privacy, this is the benchmark they use they try to improve their Panopticlick score. Cool. So one last thing I want to say before I start talking about countermeasures is that the way this actually happens in practice is that most fingerprinting code will figure out for each piece of fingerprinting endpoint I want to target, I'll figure out some way to hash that value. So people are familiar with hashing and this kind of thing. So some way to derive some semi-unique value based on arbitrary input. and I'll map, say, the number of fonts I can find into a hash, and I'll map the height and the width into a hash, and whatever else, and then I'll hash all those together, and I'll store that in a database somewhere. So you can think about my fingerprinting value is some 256-bit hash value or something like that, which has a nice implication that if you poison one of these values, if you change one, you'll change the outcome, which ends up being, does that make sense? So if I can lie about one of those things, or I can make one of those values random, I can probably, at least in a not sophisticated fingerprinting implementation, if I can just make, say, if I lie about the user agent string every time, I can get a unique fingerprint every single time. I just need to get one, like to poison the well in one place to get the entire approach to fail. That's not always true, but that's often true. Okay, so I want to, boy, we're short on time. Maybe I won't do this.
You have 30 minutes.
Maybe there's time for this. Okay, yeah, let's do this then. Does anyone not have a laptop or a machine with them? Okay, then I want everyone to go to fingerprint2.js. This is probably the most popular fingerprinting library online. There's an open source version and a paid commercial version. You should be able to find it with just a simple search. And then pair up with someone next to you, or maybe pair up in threes, some group like that. And then just take 5 minutes, read through the code, and then let's try to enumerate as many different fingerprinting approaches as we can find in fingerprint2.js. So if anyone has any trouble finding this, let me know.
Is it val/fingerprint?
Yep. And so in the GitHub repo that you probably found, there's just fingerprint2.js actual script, and it's a human readable version of that, like a non-compressed, non-minified one. If anybody has trouble finding it, let me know.
So we open up the file called fingerprint2.js in that repo, and then look through the file to try and figure out what are the
just
mechanisms they're using.
see how many different mechanisms you can pull out of that file. This is shipping on a large number of websites, so you can think about this as semi-representative of how fingerprinting is actually happening in the wild. And I'll call it in 3 minutes for them. See if I can bring it up. Yeah, right. I didn't even think of that. Oops. Maybe just call them out as you see them. Sorry, I'm going a little bit long. If you found one, just shout it out.
To see rotation, like the orientation of your device.
Yep, so your browser, and most browsers unpermissioned, allow you to determine using the gyroscope. Am I holding it like this? Am I holding it like this? Am I holding it like this? And sometimes at what angle, and you can use that to uniquely identify people. Yep, so you can, there's two different, if I remember right, at least the last version of Fingerprint2.js I saw, there's two different ways to fingerprint people using the audio API. One is just to ask about capabilities. The other is to generate audio and then see, similar to canvas fingerprinting, see the very subtle differences that happen in the generated waveform and then hash that and turn that into an identifying value as well. So my audio card may do that in a slightly different way than your audio card. Yep, so if you're using WebRTC, you can say, tell me the names of the devices that are on here. So that will be either the labels or unique IDs for them, depending on the permission you have, and that will be largely identifying.
See by fonts. So they have fonts.
Yep. Yep, it's pretty brutal. Yep, also hard to lie about that one. Yep, also extremely hard to lie about that one in a way that's not going to break websites.
Whether the device supports touch or not.
Yep, again, also hard to lie about.
Plugins you have.
Yep, so thankfully most browsers don't have plugins anymore, but that makes it very identifying if you do have a plugin installed. If you have a weird old version of Java around, that will probably very quickly uniquely identify you.
Why don't we try to use the IP origin to try to like parse the geographical location?
Say more. I'm not sure I follow what you're saying.
Oh, why don't they, like, when they get a request, right?
Uh-huh.
Can't they, like, keep track of where the IP, what the IP address of the user is?
Sure.
Why don't they use that to try to figure out, like, where they're, like, approximately where they're located?
So people do exactly that. There's a company called MaxMind, I think their name is, that sell like the most popular IP address to geographic address mapping. Two things. One is that IPv6 makes that a little bit more difficult, although not impossible. NAT makes that more difficult, and as IPv4 space has been kind of all consumed, those are no longer consistent. So you don't get the same kind of geographic per /64 mapping that you did before, that kind of thing. Just IP allocation has gotten much more scattered as address has almost been consumed.
If they're trying to track IP, you can just go into VPN and your IP is completely different.
Yeah, there's an approach called IP cookies, which is basically if I can figure out a unique set of IPs that somebody has seen before, I can track them with that. But exactly as you say, Tor makes that difficult, VPNs make that difficult, NAT makes that difficult.
But then is it possible to get your system device and get the IP and look at it and be like, oh, the two locations don't match?
Sure, yeah. So there's actually a paper, it's not doing that, but there's an interesting paper I can refer people to that identified people based on places where a privacy-preserving tool would lie in an inconsistent way with some other value. And so say you install, I can't think of the worst offender, but say as a toy example, you install some arbitrary canvas fingerprinting protection extension. There's like 1,000 of these things on the Chrome store. And so it'll like lie in some places and say like, oh, this person is in an English-speaking region and whatever. But if I also look at this endpoint, it says my preferred language is, Spanish or whatever else. And so unless you lie the right way across the entire system, you actually probably made somebody more identifying than less identifying. So that approach gets to be extremely complicated. Anyway, well, I won't belabor the point anymore. But the more you look at Fingerprint2.js, this is not even the most sophisticated version of this, but you can. I just mean that as an example of one, how it's actually done in the wild, and two, kind of how difficult a problem this is to kind of fundamentally deal with. Okay, so that's fingerprinting. In a nutshell, that is not even that's not even close to a complete list of ways that people are doing this, but that's, I hope, some representative examples. Now, how are people fighting back? So there's kind of, at a high level, 5 ways you can deal with this. One is you can just remove the functionality. So you can say, I'm not going to let people draw canvas anymore, or I'm not going to let people read the value out of canvas, or I'm not going to allow people to read fonts or whatever. That's one approach. Another approach is to say, I'm going to preserve the functionality, but I'm going to make it consistent. That kind of boils down to the same, or scrapes down to the same thing, but it's at least conceptually different. So I'm going to make every browser as much as possible say the same thing, or put them in some anonymity sets and make the functionality consistent. Third is going to say, we're going to lose this battle. There's no way we're going to actually get this right. So instead of trying to muck with how functionality exists, we're going to just try to keep most sites from accessing it. So maybe the first party gets to do some things, but the iframe in doesn't get to do it, that kind of thing. There's a bunch of approaches to that. The fourth is noise or randomization. That one I think is probably the most promising, at least for like the current arms race. I'll talk about that in a little bit. And then fifth is this proposal out of Google for something called privacy budget, which is a generalization of this idea of we'll let people do some things, but we'll stop them after a while. I think this is a very bad idea. I'll talk about why. Talk about in a bit why I think it's a bad idea. Okay, so easiest thing to do is just delete the API, right? We're not going to have a navigator.useragent anymore. We're not going to have a navigator.device concurrency. I think that's what it's called. That kind of thing. We're just going to remove it. In many cases, this will work because the vast majority of this functionality is extremely rarely used. The number of bad cases in almost literally every case dwarfs the number of benign cases. I can't think of a single exception for fingerprinting stuff. I bet there are if we thought about it, but for the vast majority of these things, they get used for bad things way more often than they get used for good things. But you can see that this is going to break stuff too. Like in that benign set of use cases that people actually care about, all of a sudden you've broken the website. And if you are a company like Brave who makes a browser that you want people to use, that is a losing long-term strategy. So instead, we can just make it consistent, but this has the exact same problem. This isn't really that much better. You might preserve some like JavaScript code paths or something like this, but at the same time, if you're returning a consistent value, you might as well return no value. You've broken the functionality one or the other. This approach I think is much more promising. So there's a whole set of categories of ways of saying we're going to allow the functionality in there, but we're going to reduce the number of parties that can access it. So permission prompts are the most obvious way. There's, for example, a geolocation API where the website can ask your phone or your laptop or whatever, give me the lat long of the person with some arbitrary precision, and understandably, the browser will prompt and say, do you really want the website to do this? That kind of thing. Permission prompts are a useful approach, but there's a well-documented phenomena called permission prompt fatigue, which is basically people will very quickly just say yes, 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 or turn the site off or whatever. But asking people to cognitively manage device functionality is an unreasonable thing to ask the most users. It's not user-serving. It's not a scalable approach. So maybe we can reasonably address just the most egregious cases or the most powerful functionality with permission prompts, but it's not going to be a way of covering 50 different fingerprinting endpoints. User gestures are a term of art, which means that they're standardized, which means a user has clicked in a page or has done some other subset of things that means the user is intending to interact with the page. So clicking is one, hovering for I don't remember the complete list, but the main one is clicking. If a user clicks in a thing, the browser considers it a user gesture, and maybe you can use that to say, we only give frames that have user gestures access to functionality. The other one is this first party versus third party distinction. That seems pretty obvious. If I visit, I don't know, CNN.com, I trust CNN.com to do some things, but I don't trust, Google Analytics to do some things. And then site engagement is this proposal out of Google that is kind of like a user gesture writ large that basically says, we have a whole bunch of signals that we can draw from. One is like, how often does a person go to the website? Has the user added this bookmark to the site? Has the user added it to the homepage of their phone? Has the user clicked there? Has the user whatever? And from that, we can derive whether or not we want to give permission. I don't like this. That would be an improvement over the current state of art in a number of ways, but I don't like this approach for several reasons. One is that it's just impossible to reason about in a predictable way. So if I'm writing code, I have no idea what functionality is going to be available to me at any given time. That becomes extremely difficult to reason about. And it's very hard to describe to the user what's going to happen to their privacy given some machine classifier. So I understand the intuition behind it. I think Google's plan is to ship it at some version in the future, although not currently doing so. I don't like this idea. I like this idea very much, though. So are people familiar with stenography? Stenography is this extremely cool way of saying, like, I have two images, and I'm going to find ways to embed data in, say, an image or a piece of audio or some sort of media in a way that's not perceivable to a casual observer. And so there's a number of approaches to inject noise into high entropy fingerprinting endpoints using stenography. So the example here is, this is not a real example, of course, but basically there's some very, very subtle difference between these two things. To a casual observer, they might as well be identical, but if you're going to read the bit values back out of the image, they would be different. So maybe what we can do is, instead of trying to make everything consistent across browsers, we can make every single canvas read different. And so if I just say change the highest order bit of every single 32-bit image identifier or image pixel, then users will not notice that, but any fingerprinting technique that attempts to read the canvas will fail. Or it won't fail, it'll just not be useful for identifying a person. Does this make sense? Because I think this is probably the most promising way forward, at least on a couple of different approaches. There's been a couple of papers that have proposed doing this not just for images, like Canvas, but also doing it for audio, for doing it for video. Brave is planning on shipping this for user agent strings, so that wouldn't actually be stenography, but for finding the bits in a user agent string that we can consistently change, or that we can frequently change without breaking websites. So maybe we'll change the least significant bit in OS X's user string. So sometimes it'll be 15.0.0, and sometimes it'll be 15.1, whatever. And so if somebody's using this like hash all the values together technique, this will be an effective way of providing privacy. The downside is that this is also easily circumvented by the fingerprinter, right? If they notice that you're doing this, they'll just drop these, but at least you've removed some techniques from the field of play. And then the last is this privacy budget proposal that's coming out of the Blink project right now. This is, I think, a terrible idea, and the Google folks they like it. But I don't think anybody else. I think this is extremely unlikely to ship in Google and 100% in Chrome, and 100% not going to ship in Brave or Safari or anybody else. But the approach here is to say, I know that there's 100 different fingerprinting endpoints, and this one adds 1 bit of identification, and this one adds 13 bits of identification, and whatever. So I enumerate how identifying each endpoint is. And then I'm going to say, I allow users to be identified with a precision of 1 out of 1,000 or whatever. And so once I've triggered enough bits to identify somebody with more precision than 1 in 1,000, now I'm going to start imposing privacy practices, some sort of privacy protections. It's a very intuitively appealing approach, but I think it has some really catastrophic problems that make it not worth taking seriously. So first is that, what do you do? You still have the same problem of what do you do once you've exhausted your budget? Are you going to break the website then? What is the lifetime of the budget? So if I revisit the page, do I get 20 more identifying bits, in which case game over? Or is it, what is the scope of the budget? So if I have include a third party on the page, does it get its own privacy budget, in which case the game's over too, because you can just move identifiers back and forth? Or if not, if there's a shared budget for the entire page, does that mean the third party can exhaust the first party's budget? That also seems like a complete game changer, that Google Maps can kill the functionality of the first party page, like you've broken all your isolation at that point, et cetera, et cetera, et cetera. Anyway, I mention this just because it's like kind of the new hotness in this kind of stuff, but I think it's a trash proposal. And I would bet my fingers that Google never ever ships it, but that is my casual interpretation. Okay, so we have 15 minutes. So let's do this quickly then. So my idea is I think this is worth doing. So pull, with somebody sitting next to you, choose another example out of fingerprint2.js and propose a countermeasure. Using one of the 5 approaches we did or something else that comes to mind, choose just one example and then figure out some proposed way of solving that. So I'll just wait. Let's just take 3 minutes to do that, and then I'm curious to see what people find.
They'd still be able to detect if they tried to embed like that. They could embed like Flash plugin and then it worked. So really also so like if Flash is installed, they're gonna be able to just have like a whole like sandboxing layer and like times that like embedded JavaScript. Like the developers have to
Yeah, so but the problem is that third party actually is.
But I think usually the first parties are kind of not very.
What about screen?
They're so heavy kind of third parties with their website is not track some ad work. Maybe they're not.
Do not track is probably used to track.
They don't.
That it is to
Because they want to make money from that.
Yeah.
Okay, all right. Sorry, that's not quite 3 minutes, but let's call out some of these real quick. Who, especially someone who hasn't raised their hand yet. Someone suggest one. Someone in the back. That's one that someone tussled with. Okay, sure.
We use Ford maybe like having like sandboxing or like.
Sorry, which endpoint did you choose first?
Oh, this is more in general, but it could be like pix ratio or any kind of like important identifier like device memory, whatever. I think it's kind of like sandboxing layer for like third-party JavaScript in the same way there's like source control. But the scenario then means that the developers of the website, the first party, can control what the third parties can access. And there's really an incentive scheme for first parties to limit third parties. But perhaps if you have the default sandbox, developers may be too lazy to manually add all the identifiers, and so may reduce the amount of lazy.
So I think that's a promising idea. 2 thoughts. One is that what you're describing is something kind of like feature policy, which is a way that the first party can control what third party frames get access to. But second, even if you say, I'm going to block the third party from learning about screen resolution or whatever, you still have to figure out some useful mechanism for blocking access to screen resolution. So it's a little bit, it's a good primitive to imagine, but I think you still need some practical approach for nulling out each fingerprinting method at that point. So if the fingerprinting method is the screen resolution, I still need some way of keeping the third party from getting access to the screen resolution. So I think it's a way of addressing like a primitive to apply to these kinds of things, but you still need some way of saying, how do I keep the third party from learning the thing once I've delegated it or I've made the decision I want to keep the third party from learning the thing.
Yeah, it would be an intense browser sandboxing.
Yeah.
There's one small limitation in the fingerprinting of the browser. One of the ways is throwing an error and seeing how they respond. So if there's some way of standardizing that across browsers.
Sure.
Maybe that function for Firefox.
No, I mean that's one we hadn't even talked about. But lots of browsers will at the corners respond slightly differently to different error cases. This is another way of people like particularly trying to grab version information out of the browser in a way that if somebody's lying about the user agent, they can do this kind of error case checking. Yeah, that's an extremely difficult problem to address. There's a paper about HTML5 parsing errors where people, I think from UIUC, I don't remember where, anyway, I don't remember where, but basically they enumerated a large list of ways that you could basically break browsers and get code execution by misformed HTML documents, or you could do sorts of fingerprinting techniques. And the approach there was exactly what you're describing, to standardize error conditions in HTML so that you would take this identifying information away. But yeah, I think that's a great approach. Sorry, we're really down to the wire. I just wanted one more iteration on this. Whatever your approach just was, spend 2 minutes of thinking about if you're a website, how you would fight against it. So now imagine you're the fingerprinter instead of the privacy-preserving party. What approach are you going to throw back at people to get them to not do what you just imagined? We'll pause for 60 seconds. I think it's a worthwhile exercise. All right, what comes to mind? Any example? So just throw it out. Any idea? Or if you were a fingerprinter who saw somebody doing this, what would you do? At least I can tell you some things that I see people doing, which are we are going to make the failure as catastrophic as possible. We're going to spin loop. We're going to throw up warnings. We're going to request additional permissions. Basically, we're going to make the website so intolerable to use that the tool vendor will roll back. They would rather unbreak the site than they would impose the privacy restriction. There's a large number of mechanisms for doing this. They're all extremely ugly and not user-serving, but there's endless stories about websites intentionally, or trackers intentionally breaking websites to try to up the game and prevent people from protecting their users. Okay, so let me jump over this. I just want to wrap up by talking about what Brave does, and then briefly at the very end, some final thoughts. So this is what Brave actually does. This is what we ship currently, and a couple of points about what we're going to be doing in the future. So Brave's privacy primitive, or like privacy, conceptually what we do is we have something we call Shields. Shields is a bunch of privacy tools basically behind a single toggle with some granularity below it. And it does a bunch of different things. It's on by default for every website you visit. But if you're one of these cases where you're breaking a website, we allow you to turn it off. The main thing we do is we have this cross-site tracking blocking, which does a number of things. Mostly, it consumes a bunch of lists of known URLs of trackers. So these are things like EasyList, Easy Privacy, uBlock Origin ships a list, we generate our own list, et cetera, et cetera. But these are just enormous lists of 70, 80, 90,000 rules identifying URLs that are associated with tracking. And so every time you request a URL in Brave, we run it through the system where we say, this looks like a known tracker, we're not going to block, we're not going to even load it. That's the main thing, that's the first line of defense. Oops. So yeah, we consume lists from a whole bunch of different different places. Some of these are hand curated. So Easy List and Easy Privacy are just maintained by, like, they're crowdsourced. Disconnect is a commercial list that's used by Firefox that's manually verified. uBlock Origin is probably the best privacy extension online. So if you're not using Brave, uBlock Origin is probably the next best option. But they also generate a list. Then Brave generates a whole bunch of lists in-house.
Do all these lists just get downloaded into your browser, or there's like your query online?
It's all local. So if it was online, it would be the obvious privacy harm of advertising. No, this is all done on site or on client. Next thing we do is we just by rule don't send third-party cookies to anybody. There are a extremely small number of exceptions we do to unbreak sites, but to a first approximation, we just never ever send any identifying information that we can avoid to third parties. So this is blah. Sorry, really short on time. And then last is we null out a whole bunch of fingerprinting stuff. So so by default, we just turn these things off. So those endpoints are just dead by default on third parties. For first parties, we allow access to them. There's some kind of, there's a bunch of different plans we have going forward for how to be more sophisticated on this. I can talk about those in detail if people are interested, probably afterwards. But the point is that our initial approach is pretty dead simple, but also seems to be successful. We'll need to keep pushing it further, and this is kind of an area of active research. Sorry, there's just 5 minutes left, so I just want to wrap up with a couple of things. So one, if you're interested in if any of this is of interest to you, we have internships. We are interested in collaborating with people. We have in and out of house collaborations. So if any of this is interest of you, let me know. Reach out to me. It'd be interesting to figure out ways that we could work together. Second is that, so Brave is mostly focused on the web. Most academic research is focused on the web because it's an open system and easy to measure, but it's not at all clear that this is the worst place where people are getting harmed. Arvin, the guy I mentioned before, just put out a paper about the privacy implications of IoT systems and how kind of catastrophic that is. Your apps are leaking privacy violating information in all sorts of ways, et cetera, et cetera, et cetera. So the web is one part of the problem, but it's definitely not all of it. Third is that as people are graduating and taking on jobs or writing code themselves, just totally reject the framing that privacy is a feature, a thing that you're adding to the system. Think of it as a fail state. If you're harming your users, that is not a feature you're not giving them. That is physical. That's innumerable harm that you're doing to people who don't realize that you're harming them. So anytime someone says privacy is a feature, they put it as a sticker on the box. It's important to have privacy, but I just reject that framing. And the last is, you're all at an elite institution. You all will have an enormous amount of choice about who you work for. I just really want to encourage you to think about these principles as you're choosing who to work for. There's somebody who said the first way to think about an employer is, will I be working on projects that make powerful people more powerful over weak people, or will I be working on projects that make weak people stronger against powerful people? And if the job you would take puts you in the first category, I would think deeply about that. And with that, there's only 3 minutes left, but I just want to say thanks very much for your time. It's been an honor to get to talk to you, and yeah, if there's any questions, I'd be happy to answer some questions. Cool. Yeah, if there's any questions, shout it out. Otherwise, I don't know, bathroom break or whatever.
Do you think our privacy could be protected by laws and regulations? Is that possible?
Yeah, so I think that's really an interesting front too. So a couple of thoughts on that. One is that Europe right now has this preeminent legislation on this system called the GDPR. And because Europe is a large market, and a relatively wealthy market, there's a lot of work, including Brave is doing, to basically try to hold international companies to the standard of European legislation. That has been very useful. I can talk about specific instances, particularly where Brave and companies like Brave have gone after advertisers, and it seems like we're very successful there, though it's still early days. The other is that there's legislation that is getting better at a slow rate, but better in the United States. California is passing what will be the strongest privacy legislation in the United States. It's not as strong as the GDPR, but it's good. And there's a particular piece of interest in that legislation that's called dual purpose, or I might be saying that slightly wrong. But the idea is that if a user consents to have their data taken for one reason, the company can't use it for something else. And so if you are, say, Google, and you take information to say, we use this information to improve the quality of our products, you can't also then use that information. It would be illegal to use that information to also improve the quality of your advertising. Or to give another example, if you're Facebook and you take a phone number as a way of second factor authentication, it would be illegal to use that as a way of linking together cookies and doing the kind of stuff they do. That ends up having implications that I think people don't realize that I'm thrilled about, but it means that you can't use your Instagram data to improve ads on Facebook. You can't use WhatsApp to extract any information for any other system, et cetera, et cetera, et cetera. And so laws can be an extremely useful part of the puzzle. Last thought is that a large number of these people are not in the United States and are not bound by US laws or European laws, and it is extremely difficult to measure these kinds of things. So a technological solution will need to be part of the solution, whether or not the legal environment gets better. Cool. Any other? Oh, yeah.
So we go over particular, but with regards to that, found that you apparently have anonymous payer transactions using what was called this anonymized algorithm.
Sure.
Could you go into whatever detail as possible?
So I won't be able to do that in a minute or whatever, but the general principle is that anonymize is a way that imagines certain transactions as if they were survey results, and using, if you're familiar with CHOM mix nets, which is basically a way of mixing data by sequencing it, by clustering it in time and then pushing it back out. You can get some privacy improvement, some privacy guarantees out of how you move information on either side of the operation. The anonymized paper is its own paper, and I'd be happy to forward it or to talk in more detail about it. But it's sophisticated and not easy to talk about in a couple seconds. But yeah, it's an important part of how Brave is doing transactions. Cool. I see that that's time. So just want to say thank you again very much.
Any other round of applause?